42% of companies abandoned most of their AI projects in 2025, a 2.5 times increase from the year before. And over half of those projects used RAG. The problem isn't AI. It's that RAG became the default answer to every question. Let me set the stage quickly. RAG, Retrieval Augmented Generation, works like this. You take your documents, split them into chunks, convert those chunks into vector embeddings, store them in a vector database, and when a user asks a question, you search for the most relevant chunks, pull them out, and feed them to an LLM along with the question. Simple concept. And in 2023, when ChatGPT made everyone want to chat with their docs, RAG was the only real option. By 2025, 51% of enterprise AI implementations were using RAG. Deployments grew 280% in a single year. An entire industry, Pinecone, Weaviate, LangChain, Llama Index, was built around this one pattern. The promise was clear. Ground your LLM in real data, reduce hallucination. The reality is messier. Let's start with the most fundamental problem nobody warns you about. Chunking destroys your documents. When you split a document into fixed-size chunks, you're making an assumption that meaning is local, that a paragraph makes sense on its own. But real documents don't work that way. A contract clause on page 12 references a definition on page 3. A medical report where the diagnosis depends on lab results in a different section. A code base where function calls span multiple files. Chunk boundaries fragment all of this, and here's what multiple post-mortems consistently show. The vast majority of RAG failures trace back to chunking decisions. Not the LLM, not the embedding model, the chunking. There's a cruel paradox here. Make your chunks bigger, and the embedding vectors lose specificity. They point to everything and nothing. Make them smaller, and you lose the context that gives the text meaning. Semantic chunking helps, about 18% improvement in accuracy, but most teams are still using fixed-size defaults because that's what the tutorial showed. I'll give you a concrete example. I asked a RAG system about a drug interaction from a medical PDF. The interaction information was split across 2 chunks. The system confidently said, "No known interaction." That's not a hallucination. That's a retrieval failure dressed up as an answer, and it's far more dangerous. Problem 2. Embeddings are dumber than you think. Vector embeddings compress an entire paragraph of text into a single point in a high-dimensional vector space. That's inherently lossy, and the losses are in exactly the places that matter. Revenue grew 12% in 2024, and revenue grew 12% in 2025, produced nearly identical vectors. To an embedding model, those are basically the same sentence. To your finance team, they're completely different facts. Embeddings struggle with negation. Patient has diabetes, and patient does not have diabetes land in almost the same region of vector space. They're weak on numbers, dates, and temporal reasoning. Anthropic acknowledged this problem when they released Contextual Retrieval. Their approach, prepending context to each chunk before embedding, cut retrieval failure rates by 49% when combined with keyword search, which means standard embedding-only RAG was failing nearly twice as often. Think about that. The default approach that most teams use has double the failure rate of what's possible. And if you think that's bad, there's a benchmark that makes it worse. Researchers tested 13,628 questions. Long context, literally just putting the documents into the prompt with no retrieval pipeline at all, scored 56.3%. RAG scored 49%. The simpler approach won. RAG only outperformed on dialogue-based and multi-source queries. And it gets worse. Microsoft's Copilot, which uses RAG, provided medically incorrect or potentially harmful advice 26% of the time on the 50 most commonly prescribed drugs. RAG was supposed to reduce hallucination, but when retrieved context is incomplete or contradictory, the LLM confidently fills in the gaps with wrong answers. So what should you be using instead? Let me walk through the alternatives. Alternative 1, long context. Just put the documents in. Context windows in 2026 are enormous. Llama 4 Scout handles 10 million tokens. Gemini does 2 million. That's roughly 1,500 pages. GPT-4 does 1 million. And Gemini demonstrates over 99.7% recall on needle and haystack tests at 1 million tokens. For knowledge bases under 1 million tokens that don't change frequently, you can skip the entire RAG pipeline. No chunking errors, no retrieval failures, no vector database costs, no embedding ambiguity. You just put the documents in the prompt and ask your question. Cache-Augmented Generation, CAG, takes this further. You preload documents into the context and cache the model's internal state. Result? 40 times faster than standard RAG and 70% cheaper for stable knowledge. The ACM published a paper at Web Conference 2025 literally titled, "Don't Do RAG." The catch? Context rot. Research shows LLM performance degrades with increasing input length, even for trivial tasks. Long context isn't a silver bullet, but for a lot of use cases, it's better than RAG, and simpler. Alternative 2, Agentic Retrieval. Let the LLM drive. Standard RAG is a fixed pipeline. Query comes in, chunks come out, answer gets generated. One shot. No reasoning about what to retrieve or whether the results are good enough. Agentic Retrieval flips this. An LLM-powered agent decides what to search for, when to search, which sources to query. It decomposes complex questions into subqueries. It evaluates whether retrieved results actually answer the question. It iterates. The performance gap is staggering. On multi-hop reasoning, questions that require connecting information across multiple sources, static RAG gets 34% accuracy. Agentic RAG gets 89%. That's not an incremental improvement. That's a different category. Here's a real example. Which of our customers in the EMEA region had contract renewals in Q1 that also had open support tickets? Standard RAG can't answer this. It would retrieve chunks that mention EMEA, chunks that mention renewals, chunks about support tickets, but it can't reason across them. An agentic system decomposes this into 3 subqueries, retrieves targeted results for each, cross-references, and synthesizes. Llama Index published a piece called "RAG is Dead, Long Live Agentic Retrieval." They're not wrong. Alternative 3, GraphRAG, when relationships are the point. Standard RAG searches by proximity in vector space. GraphRAG maps entities, relationships, and dependencies into a structured graph and traverses edges instead of searching by similarity. Finance, legal, and healthcare are adopting this fastest, domains where connections between entities matter more than textual similarity. What subsidiaries of Company X have pending litigation in jurisdictions where we also operate? Vector similarity cannot answer this. Graph traversal can. You don't always need GraphRAG, but when you do, Nothing else comes close. Alternative 4. Stop putting your database into a vector store. This one drives me crazy. If your knowledge base is a product catalog, user records, or financial data, congratulations, you have a database. Converting structured data into text chunks and embedding them is actively harmful. You're taking precise, queryable, structured information and turning it into fuzzy, approximate, unstructured vectors. Text-to-SQL is the answer here. The LLM generates a database query, executes it, returns the exact answer. How many users signed up last month? SQL gives you a number. RAG gives you a guess. Now, in practice, the winning approach in 2026 isn't picking one of these, it's combining them. Hybrid search, combining BM25 keyword search with semantic vector search, jumps recall from 0.72 to 0.91. That alone is a massive improvement for any system that still uses retrieval. Fine-tuning encodes style and behavioral patterns into model weights while you retrieve facts externally. The 2026 pattern isn't RAG or fine-tuning. It's retrieval for what changes, weights for how you respond. Here's the decision framework. Small static documents under 1 million tokens, long context or CAG. Large dynamic corpus with frequent updates, RAG with hybrid search and re-ranking. This is where RAG genuinely shines. Multi-hop reasoning across sources, Agentic RAG. Structured data, text-to-SQL. Same queries repeated at high volume, CAG with prompt caching. Entity relationships, GraphRAG. So, here's the real takeaway. RAG isn't dead. Naive, one-size-fits-all RAG is dead. The companies winning with AI in 2026 aren't the ones with the most documents in their vector stores. They're the ones who asked, what does this data actually need before picking the architecture? Your knowledge base deserves better than being chunked into oblivion and searched by vibes. The right retrieval strategy isn't the one everyone else is using. It's the one that matches your data.